Okay, so the radar demonstration is in the other video. In this video, I'm only presenting the range accuracy, as in range comparison between the ultrasonic sensor and ground truth from a laser-based distance measurement device. Uh, so in this experiment, what I'm going to do is I'm going to take a cardboard box, I'm going to place it at certain distances, like the points that are like 10 centimeters apart from each other, and all the way up to the wall. And I'm gonna take the readings um, from both of them and compare the readings. Now the thing is, I've already taken the readings to save on time, and the readings are right here. uh, as you can see, they're pretty close. However, I am going to present a few extreme points. The first point would be the closest point. Then the next point would be somewhere in the middle, and the last point would be the wall. And we'll see what we get. Okay, so I'm just gonna place it very, very close, and I'm gonna make this perpendicular. And now I will take the range reading. Oh, by the way, this line is the reference from where the distance is being measured. If you look at it from the top, it is pretty much aligned with the sensor's thing. And this is also aligned with that line. So I'm just going to take the range reading now. So it's saying 16.6 centimeters. I'm going to zoom in there. 16.6 centimeters. And the ultrasonic sensor is saying 18.3 centimeters approximately. Now I'm going to move this box somewhere in the middle. Just gonna place it there. And I'm gonna just align it. Okay, done with the alignment. I'm gonna come back and take a distance measurement. If you could focus. So that's like 96.7 centimeters, and the ultrasonic reading is 96.3 centimeters. Now what I'm going to do is I'm going to take the box away entirely, so there's nothing in between the wall. Why isn't the camera focusing up? Nothing between the wall and the sensor. And now I'm going to take the range reading from this guy. It's 184.7, and the reading from the ultrasonic sensor is 184.7, approximately 184.7. The thing is, there's no chance of an echo in this room, because there's like no object nearby that could probably reflect anything. So that's why I'm not getting erroneous readings right now. But a problem with this sensor is that it cannot measure the distance in a straight line, because the thing is, the waves that come out of this, they are always like diverging, and they have like a cone of divergence which is of 15 degrees approximately, according to the data sheet. So because of that, if I placed some metal object here and I placed another metal object somewhere here, even though they are not exactly in its path, there's nothing actually in its path, I'd still probably not get the right readings. I'm just gonna move that a little. Sorry for that. Are the readings fluctuating now? Okay, so there's nothing actually in its path, right? However, the reading should have been 184, but it comes out to be 112, and that's not correct. I mean, the true reading is still 184, and the reason why it's happening is because the waves are coming out of this, bouncing from that, and then coming back to this. So it's actually taking the wrong distance. These waves actually come back earlier as compared to the waves that bounce off from the wall. So That's pretty much why you have these errors, and these errors are uh, more they occur more often in a real world environment, because in a real world environment you have a lot of metallic objects like cars, bikes, the silencers of bikes and all that. So those things cause huge errors. Another thing that can cause error is the temperature, humidity, and the pressure, because right now I'm in my room and the temperature is roughly 27 degrees, but if I were to go outside, I would have to recalibrate the sensor, as in I'd have to change uh, the speed of sound constant, because the speed of sound would be slightly different outside my room. Now, if we come back to the error that we saw in the beginning, which was the difference between the true reading and the ultrasonic reading, the ultrasonic sensor measures a slightly larger distance as compared to this one, the true reading, because the distance measured is basically the average of this distance and this distance, and it is not the the this distance basically. And as you can see, this distance would be greater than the vertical distance. And the thing is that distance, the difference in those two distances, it becomes negligible as your distances become larger and larger, because the angle becomes more or less 90 degrees, so it sort of becomes a lot more accurate as you increase that distance. So yeah, those are the few problems. The first problem being this thing, which is if you were to be very close to this sensor, it would give you slightly inaccurate readings. The second problem being that if you had metallic objects in the environment, then they produce echoes. And another problem that you can face is if you were to implement this on real world self-driving cars, that would be a really, really bad idea, because if every single self-driving car had an ultrasonic sensor and, well, an HCSR04, then you would have huge problems, because if I have another car which has like sense these ultrasonic sensors, this is another kind of ultrasonic sensor. If they have sensors and that is also on another car, it will get interference from the other sensors, and that will cause huge problems. So yeah, those are the three main reasons for the errors. Well, there are actually only two: the echoes, other ultrasonic sensors or other sound sources in the same frequency range, and uh, the temperature and humidity changes.